Table 8.1 draws our attention to different kinds of colloids. We said that clay was a major kind of colloid. We also said that organic matter was a kind of colloid, and we said there were some other ones as well. So what you can see here is we'll highlight the ones that are clay right in here. So those are actually what we would consider clay particles that are a special kind of particle called colloids, and we've discussed that in the last video. These here, aluminum and iron oxides, are also colloids, very small particles, and they have a certain way that they will act, a certain charge on them as well. It tends to be positive, and we'll see in just a second. Another group of the non-crystalline, I guess we could say mineral-looking sorts of colloids, and then finally the humus, which is the organic matter that's in the soil. We'll discover what this type is later, especially in terms of the clays. You can notice the size as well, very, very small particles. The shape is important, so we have flakes and plates, and sometimes we don't have any fixed shape. Hollow spheres and tubes, variable, amorphous, which means there isn't really any shape. It's kind of like a blob that always forms differently. The book makes a special point to tell you that colloids per mass of soil have a very high amount of surface area. So when we're looking here and we see something like 80 to 150 square meters per gram, okay, square meters per gram, that's a lot of space, right? So if we had, let's just say we had 100 square meters, that's 10 meters by 10 meters of, just think about it as floor space. 10 meters by 10 meters, roughly, let's say 30 feet by 30 feet of floor space. So 100 square feet of floor space, in terms, that's a surface area. We have that same surface area in just a gram of this material. So very, very high amounts of surface area per mass of soil. That's an important quality, because that lets you actually hold a lot of water on those surfaces. If you have a lot of surface area on your soil, you have a lot of surface area to actually put water on those. Now this is very high compared to something like silt or sand, as we'll see in the next video on Figure 8.2. You'll see why that is and how that can be. Some of these have some internal space as well. So in between the plates, or in between the flakes, you have some space to attach particles and water and things like that. Finally, you'll see the net charge, and that is, do these particles in this category exhibit a negative charge within themselves, or positive charge within themselves? We can have particles that have more negative, as you see these here. The clays have typically always negative charges. Okay. Organic matter typically has a very negative charge. But these in here, these ones are a little bit different. Allophane, this word here is called goethite here, gibbsite. These have the possibility of having actually a positive charge within them, and exhibit a positive charge, so negative particles floating around in the soil solution can attach to those soils. And it differs. Some have very high negative charges, like vermiculite, and some have even higher. So humus is very, very high negative charge, and some don't. Some things like kaolinite, which is a form of a clay, it isn't very reactive. It has some negative charge, but it's nothing compared to smectites and vermiculites. These up here. So there's a categorization of a pecking order, if you will, of who has the most charge in the soil among the soil colloids.